You guys ready to roll here? Everybody have everything out here? I want to get through this last example, guys. This is kind of a, I don't want to say it's difficult, but there's some steps involved in this right here. We talk about partitioning a directed line segment in example 5, and it's like, well, what the heck does that even mean? And, not terribly impossible to do, but I'm not sure without seeing step-by-step to this, you'd know how to do it right off the bat. So let's kind of talk to this right here. Guys, I'll read this right here. I've got a line segment that starts at what point? Starts at C at -4 or 5 and goes to where, kids? And that ending point is 8, -3 right there. So guys, I'm going to read this. It says, find the coordinates of point F along the directed line segment CD. So that means start at C, end at D. So that the ratio of CF to FD is 3 to what? 5. Okay, now I want you to think about this. Okay. If I said a ratio of 3 to 5, it'd be like me saying, I'm going to give Garrett 3 of something, and then I'm going to give Holden 5 of something. Okay? That'd be a ratio of 3 to 5 right there. But think about the person that was giving out the 3 and the 5. How many things did I give out? 8. So of the 8, how many did Garrett get? 3. And how many did he get? 8. So if we talk about fractions, we would want a 3/8 ratio to not 8, but a 5/8 ratio, wouldn't we? Okay? So here's what we're talking about. When you do these right here, guys, the first thing I'm going to do is have you look at the ratio. Look at your ratio right here to get a total. All right, always get a total first. Okay, 3 to 5. It's like I gave out 3 things and 5 things. How many total things did I give out, kids? 8. Okay. So what we're trying to do is to cut this up so that one segment is 3/8 of the original segment and the second segment is 5/8 of this segment. Okay, so here's how I tell kids to work this. Step 1. Okay, I always say start with your first number in the ratio. What was the first number in that ratio? So we're going to put the first number over the total. What was the total, kids? Okay, so I'm going to say step 1. Take your first value in the ratio and compare it to the total. We're going to take 3/8 of it. We're going to go 3/8 of the distance from C to D to find that point F. Okay, so 3/8 is going to be a fraction that we're going to use here first. Okay, now step 2 here, kids. Here's what I tell kids. Count your change in X. I'm going to write change in X as delta X like that. That little triangle just means change in X. And if I count my change in X, I better count my change in what? I'm going to say from start to end. Okay, so let's do that, kids. Okay, if I start at point C right here and I go all the way over, kids, how far over do I go? A couple ways to look at it. What's the X value of my starting point here, kids? What's the ending value of my X value down here? 8. So if I start -4 and move up to +8, how much change is that? It's a +12 change, isn't it? Agree? Then I also need to be, and I'm going to write this up here. That +12 equals my change in what variable, kids? X or Y? That's a horizontal change. So is that a change in X or Y? Yep, that'd be my change in X. Okay. Let's do my change in Y's, guys. Am I going up or going down now, kids? Going down. Okay. A couple ways I can count it. This is a scaled out by 2. Looks like. But I can also look at the Y value. So I'm going from a Y value of 5 to a Y value of what here? So going from 5 to -3 would be a change of negative how much? -8. Yep. Okay, so I'm going to put -8 right over here, friends. And that's going to equal my change in Y. Cool with that, my friends? All good? Okay, so here's what we're going to do, kids. All right, once you've counted that, the third step. Okay, and I'm just going to write it right here. Take, and what ratio are we going to use here, or what fraction are we going to use here, kids? In this case, we would take 3 out of a total 8 Okay, so we're going to take that fraction. We want 3/8 of the distance. We're going to take 3/8 times your change in x and change in y. Okay? So help me out, my friends. What was the change in x again? So we're going to do this. We're going to go 3/8 times 12. And that's going to give us how far we should move our x to get to a ratio of 3 to 5. And then we're also going to take 3/8 times what other value, kids? What was our change in y? -8, right? Okay. Anybody have a calculator handy for me right now? Ben, you want to punch numbers for me? Ben, would you be willing to do 3 times 12 divided by 8 right here? 4.5. I'm going to write down here 4.5, and I'm going to highlight that. Okay. In fact, the 4.5 is going to be the change in x that we want. Okay. Okay. And then, Ben, I need you to go 3 times -8 divided by 8 and tell me what you've got. That would be like our change in y that we want because we took 3/8 of the total. And here's what we do in step 4, kids. We're going to say add your step 3 values to your starting point. Okay, so kids, it said we were on a directed line segment. Directed line segment C to what? D. Implying that we start where, friends? Okay, so let's just do that. My start point is C, which is what coordinate, kids? To that, we're going to add our changes. All right, we're going to add step 3 values. Okay, what values do we get for step 3? What was my change in x? How much change in x do I want? So we partition this into a 3 to 5 ratio. What did I highlight right here for change in x that we want? 4.5. I want a change of 4.5. And then what did we highlight for our change in y that we want? -3. Okay, here's what we're going to do. We're going to total these up. Okay, and my solution is going to be right here. Okay, kids, help me out. What's -4 and 4.5 add up to be? X is 0.5. What's the 5 and -3 combined to when you add them up? 2. Okay, so we think the point is what coordinate, kids? 0.5, 2. So let's go back to our graph and check this out. Okay. Guys, 0.5, 2. This graph goes by 2's right here, but isn't the y value of 2 right there, kids? Doesn't that look like 0.5 maybe right there? Because this is going by 2. 1 would be right in the middle. So doesn't that look like the coordinate 0.5, 2 right there? Okay, so I'm going to go ahead and I'm going to say, I think the 0.5, 2 is going to be right about here. And I'm going to call that coordinate F. Okay. Guys, what did we say the ratio is going to be split up to in the beginning? 3 to what? 5. Okay, going from C to F, it means for every 3 units from C to F, there are how many units from F to D? Okay, does it make sense that C to F is shorter than F to D? Because C to F gets 3 units for every 5 that F to D gets. Okay, so let's just kind of summarize right here. What's the first thing we want to try and do, kids? What did I do with the ratio first? I got a what? Total. Okay. If our ratio was 4 to 7, maybe, kids, I would have used 4 over what value for the fraction to multiply our change in x and change in y by? 4 over what total? Guys, 4 and 7. Simple. Add up. 4 over 11 is what we would have used here, right? Okay, so the first step, figure out your total, and then say we're going to have 3/8. We want to go 3/8 of the way from the start to figure out where that point is. Okay? Step 2, count your change in x and change in y. That was simple over there, wasn't it, kids? Okay? All you're going to do then is take that first divided by the total in your ratio and multiply that fraction to your change in x and change in y. Here we took 3/8 times 12. 3/8 times -8. That told you how much to change your start point by. Start wherever you are, change the x by 4.5. How much do we change the y at the start? -3. Okay? All right. So, guys, that's what you need to know for example 5 there. Kids, what questions on that? It's kind of a toughie. A lot of steps involved, but I think there's some pretty simple mathematical steps that get you to the end on that. You guys got the roadmap down for that? Okay. All right, kids, here's what we need to do today. All right, I'm going to put the lunch schedule up